Okay, I'm back, and it is time to talk about Chapter 3, which is going to be covering the mechanisms of attention. How do we monitor and notice information? All right, so let us get started. First, let's just talk about the basic characteristics of attention. Oh, before I get too deep into this, I just want to let you know it's a warm day. I've got my window open, and so if there are strange noises in the background, I apologize for that. But I will pass out from heat if I don't have the window open because it is summer while I'm recording this. Okay. Anyway, so first off, one of the things that we really have to understand about our attention system is that it has a limited capacity. There's only so much that you can pay attention to at one time. It's flexible. You can shift your attention without even noticing that you're doing it, or you could do it on purpose. You can move your attention around so that you can see different parts of the environment or hear different parts of the environment or hop back and forth between seeing and hearing. So it is flexible, but it's really super important to remember that there's only so much information that your attention system can manage at one time. Like I said, it's voluntarily controllable. You can decide what to pay attention to. It's like you place a spotlight on whatever information you're going to pay attention to at the moment. And just like a spotlight, you can move it around. Sometimes you can discover that the spotlight has moved because your attention got pulled for some reason. But whatever's in that light is what you'll be paying attention to. And everything that's non-illuminated is, for all intents and purposes, not even happening because your brain is just not aware of it. So before you start to pay attention, before you have decided to put that spotlight on a particular aspect of the environment, you will undergo what's called pre-attentive processing. What that refers to is, before you become consciously aware of the stimulus details, you, without any effort, shift your attention onto that object. So a lot of times there are certain kinds of stimuli that really grab your attention and trigger the beginning of this pre-attentive processing. And we'll talk about that as we go on. Post-attentive processing refers to the kind of processing that you do after you have become aware of the fact that you are paying attention to something. Once you have placed the spotlight onto the object, your brain will start to say, I'm paying attention to this aspect of the environment, and we'll start, investing some effort into understanding what that object is, what that sound is, what that smell is, things like that. So I thought it would be fun to do a little demonstration of pre-attentive processing versus post-attentive processing with this little visual demonstration. So I'm going to show you an image, and you're going to say how many circles are in the image. Obviously, you will say it to yourself because I can't hear you. All right. How many circles? I'll bet that wasn't very hard. How many circles? I'll bet that was a little harder. When you have a small number of objects to what we call enumerate, to say how many there are, it's a pre-attentive process. Us adults, at least, this is not necessarily true for children who are still learning counting and counting words. But for us adults who know the word 3, we can at a glance pre-attentively process up to, there's my Audubon clock. That is not from outside the window. That's my clock. I think so far, all of the times it's gone off while I've been lecturing, it's been a different bird. So it's good to know I sort of do this at different times of the day. So up to 4 individual items can be pre-attentively processed by us adults. The longer string requires some effort. And so I needed to leave it long enough for you to be able to either directly count it or recognize that you had already seen the 3 and then sort of just process the remaining 4 to figure out how many were there. But it's not the kind of thing that you can just know without having to actually spend some time, some effort discovering how many were there. So that's a good example, being able to quantify things is a good example of a pre-attention process can occur with a small enough set. Post-attentive is required for a larger set. We call it subitizing when you have 4 or fewer items. Subitizing is a a word that just describes how you can do it without having to individually account for each item. It's quick, it's effortless. You can just take a glance and you knew that there were 3. Enumeration, which is the word I used a second ago, enumeration is when you have to actually count it. And typically that's going to occur when there are 4 or more items. So that number 4, you can end up, depending on how skillful you are or how clear the items are or whatever, might be subitized, or the 4 might be enumerated depending on the circumstances. So it's sort of that cutoff place. All right, so as is always the case in cognitive psychology, we have multiple theories, or in this case, they call them models, to explain how we pay attention. And again, each model kind of explains part of attention, but none of them really coherently explain all of attention. So the filter models are the models that kind of treat our attention as being like an on-off switch. You are either paying attention or you are not. You either are aware of what's out there in the environment or you are not. So it's an on-off switch. There's nothing in the middle. There's no partial attention. It's on or off. So you can kind of think of it as binary, right? 0s and 1s. It's either on or it's off. All the unattended stimuli will be in the off position. All attention is focused on whatever stimulus you have chosen. So there are different filter models. There is the early selection filter models, which include the switch model. The switch model says that we are attracted by the physical characteristics of the stimulus. So notice that the phrase is attracted by the stimulus. So this switch model is going to do a good job of explaining those times where our attention is pulled by the characteristics of the stimuli, as opposed to, we'll talk about other models that will account for maybe your internal motivation or your interest level. The switch model is referring to those times that our attention gets pulled by the stimulus. Once our attention has been pulled, that's going to lead us to that pattern recognition that we discussed in the last chapter. So once the item has attracted our attention, then we start to try and figure out what the object is. There, in this model, there's no pre-conscious processing. There's no, semi-awareness or anything like that. In this model, unattended stimuli fade from the sensory register as if they never even happened. If you don't pay attention to it, it's like you never saw it. So this one, you have to pay attention in order to notice anything. Then the next early selection filter model is the attenuator model. And we've got a knob over here on the right. And you guys have probably seen these kinds. They sometimes are called dimmer switches in labs or classrooms. Sometimes you'll see it with these numbers that you can more precisely pick the level of illumination that the attenuator is going to give. Knobs on a stereo, which might be a click, not a knob these days. Those are attenuators, right? Or on your TV where you can turn the volume up in little increments. Those are attenuators. And so what you can do with an attenuator is apply more or less volume or more or less light or whatever the attenuator is controlling in your in your attention system. The early selection model says that the attenuator model says you can apply some degree of attention to whatever stimuli are in the environment. It's like the cascade model of processing that I introduced in the very first chapter, where the idea is you can kind of divide your attention among multiple things. But once you have fully identified one thing, then you'll apply more of your attention to the as yet unidentified object, and so on, with each one getting a little bit faster once you're shifting your attention. So with the attenuator model, attention is paid to more than one stimulus, or it's possible for attention to be paid to more than one stimulus, but none of them really receives your full attention. You've divided the attention. They're each getting part of the attenuator knob. In this model, very similar to the switch model, attention is going to be focused based on the physical characteristics. Okay, so that sounds like the switch model so far, but then attention can also be focused based on semantic characteristics. Okay, I think this is the first time I've used the word semantic, so it's really important. It's going to be something we will come up in lots of chapters. Semantic in cognitive psychology means meaning, basically. So it also can mean words. We talk about, semantic understanding being we understand, we process the material for meaning. So it could be definitional, in the form of words. It's kind of it's hard to define semantic without using the word semantic. But the idea is that you're understanding the meaning. So you've got attention being focused on either the physical characteristics of the stimulus or its general meaning. So we've got, for example, a rock, and the rock is brown and it's jagged and it has all these physical characteristics. But maybe our attention wasn't pulled because of how it looks. Maybe our attention was being pulled because somebody had holding it and had their arm cocked back in our direction, and we're aware that this means that we might get hit by the rock, and so the meaning is what caught our attention, the possibility of injury or whatever. So attention gets focused on either of these things in this model. In both of these models, though, in the early selection filter models, both the switch model and the attenuator, always remember that the stimulus is driving the attention. We are not talking about anything going on inside of you thinking, I'm going to look around in the environment to see if anybody's going to throw a rock at me. It's not motivated like that. It's motivated by the existing stimulus that then pulls your attention, and then you move forward. So it's important to remember that about the early selection filter models. All right, so let's talk a little bit about some salient physical characteristics. I was planning on having that come third, but apparently it populates first. So I'm going to talk about these and then let you lead into the motion video in a second. Actually, I can probably show you this video here on the screen because there's no sound to it. Okay, so one salient physical characteristic that will pull our attention is color. So, in a field of green, a red object would pull our attention. That would be something we would focus on. And you might notice that as I'm lecturing, it's August, and I'm always dismayed by how some of the trees and bushes start to change color in August. And I'm like, oh, come on, man. I just got done with summer school. Why are the leaves already turning? But what pulls my attention isn't all the green. It's the few trees that are having yellow leaves or having red leaves on them. That's what's pulling my attention, right? Those are salient right now for me because it feels like I missed out on all of summer teaching summer classes, and then now I'm finally on a break, and oh no, it's turning to be autumn already. So you can imagine that pulls my attention, the presence of the red in among the green. As you look at this picture, there's probably one swimmer that's pulling your attention, right? Size is another factor, and it could be the reverse. Like if everybody is the same height and then there's one that's substantially smaller, that would probably pull your attention. Orientation pulls your attention. A lot of times it seems like only just a fussy person would notice that the tile is awry, but I'm sorry, most people would be pulled if the light was right and they were at the right angle. They would be like, wow, that one tile is out of alignment, right? The orientation of that tile is incorrect. So if everybody else is upright and one object is upside down, the upside down one is going to pull your attention, right? The orientation of the object. All right, this last one, I think I can run it. I'm going to go ahead and we're going to try. I'm just going to run it in place, and in case there's sound, I'm going to have it capture the desktop. All right, so I'm going to mute myself, and you guys can watch this little demonstration of motion attracting your attention. All right, so there were clearly no sounds on it, so that's good. Hopefully it wasn't too low quality of a video for you to notice it, because I don't know what setting I'm recording this at. My son sets up my screen recorder, and so he tends to put it on like the 4,000, the 4K or whatever. So hopefully it was good enough, and you saw that motion. This is something that you might have noticed if you're ever out watching birds or looking for animals or something. You might not see it at all until it moves. And, think how protective that is for an animal that's, a prey animal, to just hold still and nobody will notice it until there's movement. And, sometimes I think to myself, why didn't you just hold still a little longer? Because now I've seen you. But they, sometimes they'll panic or whatever. And I wasn't going to eat them, don't worry. But, you can imagine if holding still, it virtually makes you invisible, and motion catches, it draws your attention, it pulls your attention. So that's an important salient physical characteristic. All right. So, how do we know whether the early filter models explain anything or not? Well, luckily, some very clever researchers figured out ways to know whether people are putting all their attention in, like the switch model says, or if they're putting part of their attention, like the attenuator model says. They designed a technique called a dichotic listening task. I swear, back in the 50s, they tried really hard just to make really complicated words so that it would sound fancier. I mean, that's all I can think of. Dichotic means that you're using both ears. So we maybe today would just say stereo listening tasks, right? Like, I don't know why they had to say dichotic. Anyway, sorry, I don't mean to judge. So what that means is you put headphones on the participant and you tell them, okay, there are going to be two different things presented in each ear. So on, one ear, there's going to be a story, as you see in this picture, about horses. And in the other ear is going to be a story about Abraham Lincoln. Okay, so the participant is told, you're going to hear two different things, one in each ear. We want you to ignore the information that's coming in your right ear. So just ignore that and pay attention. There's going to be a test afterwards about the contents of your left ear. And so what they found through these kind of dichotic listening tasks is that you really can't control the subject's tendency to switch their attention to what was supposed to be their unintended ear. They would have incomplete knowledge of what had happened in the story on their left ear, and they would say, well, I was listening and they were talking about him reading by the fire, and then I know there was something about horses galloping, and then I wasn't paying attention to the Lincoln story anymore. Even though you told them, ignore it, their attention would get pulled. So another way to know whether they are officially paying attention to what they were told, so that we could find out whether anything from the unintended ear entered their consciousness, was the development of these things called shadowing tasks. So in this task, same exact setup as the dichotic listening task, but with an additional task for the subject, which is they are supposed to out loud say every word that they're hearing in the attended ear. So as they hear the story about President Lincoln, they're supposed to be saying it. So they're probably, one or two words behind the input as they're trying to say it out loud, plus attend to what words are coming up next. Very, effortful task, and they probably have to pay a lot of attention. This really helps to prevent the participant or the subject from shifting attention. If they do shift attention, it makes it really obvious, because the person might be saying, President Lincoln often read by the light of the fire across the field, and then you'll know that they switched because they accidentally said something from the unattended ear. So it makes it possible to control what they're paying attention to. And what they found from shadowing tasks is that the subjects would oftentimes say, I don't really remember anything from the right ear. I was ignoring it. And then if you ask them just, anything, take a guess. What do you think it was about? They'll say, like, it was about horses, or give a vague characterization of the meaning, which implies to some degree they did process the information coming in from their unattended ear. Even as we watch them shadowing and having to pay attention to the attended ear, they were processing something from the unattended ear. All right, I think that's a good time to stop, because our next discussion is going to have to do with late selection filter models. So we will come back and pick up with that.